Thank you, everybody, for coming. So the title of our talk is Post-Hoc Systems Architecture, an argument for microservices first. My name is Anastas Stoyanovsky, and my colleagues here are in order Aiton Goldman and Charles Gala, who goes by Chuck. So my introduction, actually, and just who we are first. So I work in artificial intelligence and information retrieval for IBM Watson, working in collaboration with IBM Research. My background is in pure mathematics, although I also have an undergraduate background in mathematics, computer science, and neuroscience. All of those work to set me down the path of artificial intelligence. And I'll let my colleagues introduce themselves.
Yeah, I can take over. I'm Charles or Chuck Gala. I'm also a developer at IBM Watson. Similar background, like machine learning. Did some pattern recognition work in grad school, and Penn State and University of Dayton.
My name's Aiton Goldman. My background is quality assurance and making developers cry. Been doing this for about 20 years. This is actually my second time working for IBM, and I'm really looking forward to this talk. It's very exciting.
Excuse me. So let's start with an outline of what we're going to talk about. We just went through the introduction. We'll start out with some background about the general context of the discussion, which I'm sure many, if not all of us, are familiar with around microservices. And from there, we'll go with a problem definition. We have a proposed approach. It is a formalization of how things played out over the course of 2 years for us in the cloud service that we started and then shipped. We're going to give a couple examples of how the approach we're proposing worked out in 2 different cases. We'll have some discussion, and I think we should have some time left for Q&A afterwards. And we'll see whether that comes true. So first, I'd like to set the stage with an opening question, which is the question that many people ask, is should I design my new product using a microservice architecture? And that, of course, depends on who you ask. So that's not particularly helpful. It's a very general question. So let's rephrase it a little bit to make it a little bit more concrete. Under what circumstances do the benefits of starting with microservices significantly outweigh the risks? And our starting point for going forward is one scenario, which is the scenario that we had. It may be when development is happening concurrently with product design and or with shifting external dependencies. So to go back and just very quickly review the arguments for and against microservices in general before considering this more specific concrete case. So first, there are 2 directions, microservices first and monolith first. And so let's start with some of the common points made for microservices first, which are they do allow fast delivery of independent parts. It's easier to set boundaries between components during initial component creation to prevent casual code coupling. So it forces you to decouple and have independent components. And there is an argument that, on the other hand, if you do start with a monolith, there's a very good chance that you will end up with tightly coupled code, which will be difficult to break up into microservices, maybe so difficult that it's not going to be worth it. And on the other side, for the monolith first argument, there is, of course, a higher premium to maintaining microservices. There's a lot of overhead, maintenance, support, DevOps sorts of concerns. There's also, you just simply don't need it, which is a little bit of an abstract argument. But again, this is the general case. And maybe the biggest argument is that there's a high risk of getting the bounded context wrong. And this is the one that we're going to focus on to polish our question a little bit before going on. And so let's take both of these arguments into account, and let's shift the perspective a little bit. And depending on what you read and who you read about the risks of microservices, you'll generally get this idea that there's a risk there, that you're going to get the context wrong, that you're going to have improperly divided services, that your project might fail because of it, because you'll have too much overhead, you won't be able to actually implement what you need. And the perspective that we'd like to take when setting the stage for our proposal is, let's accept that that's going to happen. Let's accept that you're going to get the bounded context wrong and budget for it as part of your actual roadmap. In that case, it's no longer a risk. Under this perspective, it's just strategic technical debt. So with this idea as a basis, where can we go from there? And the question becomes, if we take this approach, how do we best intentionally take on that technical debt and then pay it off optimally? And this is the basis for our discussion today. So our problem definition is, concretely for this talk, if we accept getting bounded context wrong as strategic technical debt, how can we take advantage of microservice architecture to expedite initial release as much as possible, while also minimizing the long-term cost of strategic technical debt incurred along the way? So our proposed approach is when there is high uncertainty in product design or future requirements, but development needs to start, it can be an effective strategy to start with the microservice architecture. Viewing, again, as I said, incorrect bounded context as technical debt and not as risk, although I do want to say that this is not a suggestion that you can do whatever you want, you can make any mistake no matter how big. The assumption here, there's a reasonable effort during the design phase of doing your best. Just we know that there will be changes necessary in the future. In particular, and this is, you'll see how this plays out in the couple examples that we're going to go through. A key point here is to address new requirements and use cases with new components, although in a judicious manner. And we'll go more into this with a lot of illustrations. And so the goal here is to ship fast while tracking strategic technical debt. And after release, address only the technical debt in those in microservices that end up being mission critical. The focus there, is on increasing maintainability of those mission-critical microservices and enabling development agility. In particular, the goal there is to ignore technical debt in isolated, non-critical components until you're forced to. So again, this is a way of intentionally using the advantages of microservice architecture more intentionally and using it to isolate technical debt as appropriate. The risks that are minimized in this approach are to avoid investing in features that see no usage, but that could increase overhead, to decrease the impact of unforeseen legal or platform requirements, and we have a particularly big example of that. Allowing late phase addition of new functional requirements, although with higher debt, and avoiding unintentional code coupling that can harm team velocity. So a very natural question then is under this thesis, how do I know which tech debt has the highest interest rate? So as I mentioned earlier, we unintentionally carried out our here proposed formal strategy. Looking back empirically, we identify useful metrics for driving decisions on what debt to pay off. They're a little bit basic, they're first pass, but they are illustrative and are consistent with what we are suggesting. And those come in two categories. The first is technical debt. Which is how much code needs to be refactored, how hard is it to modify the code base? Is there a way we can actually identify which code bases these are? And high touch versus low touch. So how often does a component get modified? The idea here, as you can imagine, if something gets modified once every 6 months but is full of tech debt, well, that's not worth paying off. And we'll give some numbers and illustrate how that played out. Those metrics in a little bit more detail, we considered more than we ended up actually using. So the ones that we looked at for tech debt metrics were, could we look at a combination of repository size, average number of lines modified per PR, percentage of production log output, under the idea that something that produces more logs is either someone had to make it more understandable or it gets more traffic or both. And we use test coverage as a proxy for an inverse relationship with technical debt, under the idea that although there are many other metrics one could consider here, we took the approach of lower test coverage and probably indicates higher technical debt. For high versus low touch metrics, some of the things we looked at were the number of commits per PR, the number of comments per PR. The idea for comments per PR, and sorry here, PR stands for pull request. So the idea here being if there's a lot of discussion for a change, then maybe it's not very understandable, maybe it needs to be refactored, things like that. And the last one is the one that we actually found the most use in for this particular category, which was the mean and standard deviation of the time between commits in a code base. And so test coverage, and as I said, mean and standard deviation of time between commits, and test coverage, these are the ones that end up being perhaps the most useful out of the ones that we looked at and could provide a useful starting point. So we'll use ourselves as a case study. We informally adopted the approach here. We will give two examples of how all of this actually manifested. We'll identify some commonalities across those examples. And after each example, using the benefit of hindsight, we identify basic metrics to help make this approach both formal and intentional rather than just in hindsight. And that brings me to the first example we have, which is of our information retrieval architecture, and my colleague Chuck will take you through that.
Hey everyone. Yeah, so the first example we're going to be talking about information retrieval architecture. So going back a number of years ago, we were tasked with putting together this new cloud search offering. Basically, IBM came out to us and said, like, hey, we have this search offering. We want to make it better. We want to have more machine learning. We want to have more information retrieval. We want to have all the things. And around this time, like, we were still sort of developing our cloud platform. Our organization was still developing. We weren't even 100% sure where we were deploying our components at the time of like developing this work. So there was a lot of unknowns as we're trying to put together this product, especially because as we were doing this, there were also researchers meeting up, and we were in meetings where they were saying, like, we need this feature in order to help us stand out. And this was often like late development time decisions for us. So it was interesting. We're actually going to break this up in a couple different phases. The first one is like how we were trying to ship quickly, or in other words, accumulating this technical debt as we're trying to make our deadlines. The initial MVP, before we even got started, was this really simple architecture. We had a query service which just queried documents against a document store, and to prevent the customer from overloading our hardware, we had a Redis instance for rate limiting. Fairly straightforward. And our MVP, or at least that's what we were aiming for when we originally put together this architecture, was to have a search component that would act as sort of a intermediary between the document store and query. And this would do all the searching, like enhanced search, such as machine learning or any other enhanced IR functionality. There was a training, and then the customer is able to provide training data, which was tracked using a training data service. There were various other subsystems for doing machine learning, and then these would also interact with the document store to help enhance the customer's search results. We were feeling fairly confident when we started working on this architecture. We could make our deadlines. We were pretty thrilled with what we had, and we were looking forward to implementing this new components. And then research came back to us and said, hey, we got this differentiator component which provides functionality, and then corporate was like, okay, we got to do this. It's gonna help us stand out. We're gonna win the cloud wars, and we're gonna be the best service ever. And we're like, okay, when do you want this done? Well, we want it now. I'm like, okay, yeah, sure, we can do that. To minimize the impact on our existing work, because we were trying to make our deadlines, we added this as a external service. So extending our existing architecture, we had this differentiator so that we could easily ship and also keep things in a very maintainable state rather than trying to shoehorn code into our existing services. After that, we were feeling pretty good. No more, we could finally meet our deadlines. We were able to get everything done on time. We're cool, right? No. We also found out, because, as I mentioned before, we were working on a platform that was still like in its early stages. It was evolving. Platform came back to us and said, okay, look, we have some security requirements, and we want to make sure that only certain people have access to the customer data on this document store. And the way to ensure that is we're going to put a proxy around this, and you have to interact with this proxy now. And as shown in the diagram, we have 3 different services interacting with the document store. So we were thinking, well, crap, we have to rewrite all our clients to the document store. We have to rewrite all our testing, and it's going to be really painful. And what we were able to figure out was, by putting in a man-in-the-middle component, a reverse proxy, we were able to keep our existing code exactly the same, and then to say, like, for example, the search component would send out to this Nginx service, which was the reverse proxy, and then this Nginx component would actually prepare the actual request that the proxy expected. And by isolating this technical debt, we didn't get derailed too much to get all of this implemented on time. Yep. So to summarize all this work, we were given a lot of late work that had to get in, and we were able to isolate our technical debt as external components. By adding these deployable components, we were still able to meet our requirements. one thing we noticed while we were doing all this development was that we kind of screwed up our bounded context a little bit. We noticed that between the search service and the ML service, which stands for machine learning, sorry, we noticed there were a lot of shared concerns. They were all doing a lot of the same work between these components, and we were thinking, well, we could have written these better if we hadn't had the time and known, and we just accepted this as technical debt. What we noticed was that the machine learning component was actually a very low-touch component, meaning we didn't actually have to modify it too much. So luckily, because, even though it was technical debt, we were able to ignore this problem for a while because we didn't have to touch it too much. All this work I've been describing could be characterized as sort of an expansion phase where we're sort of growing out our architecture to deal with these late requirements. The follow-up phase is actually paying off the technical debt. So now we've grown out our architecture to meet these requirements. We can finally take some time to pay off the technical debt, put things in a better state. Once we finally had the time to actually do this work, we sort of looked through all our services and said, okay, like where is the most technical debt? Where do we need to do the most work right now? I think the most of it was in the differentiator component and the search component. Between the two, we figured that, okay, search is clearly the more important component because everything goes through search, whereas, as it would turn out, the differentiator component did not end up being a real big deal at the end. Like when we went GA, we were like, oh, no one really uses the differentiator service, so it ended up being a very low touch component, so it didn't require changes as much. So we prioritized the search component. In addition, I mentioned, a few slides back that, we kind of screwed up on the bounded context between the search service and the machine learning component. Luckily, because the machine learning component was low touch, we were able to push off that work for a bit. But then, eventually, we got to the point where there was a new feature where we had to actually update all these components. And at that point, we were thinking, okay, yeah, we can definitely. This is the time we could do the rewrites. We can merge the code together. This was the time to do that. So this is the architecture from before, nothing we haven't already seen. After doing some analysis, we figured out, we realized that search was the high-touch, high-tech component that we definitely wanted to refactor first. And we paid off a lot of the technical debt, put together a V2 version of the service that actually did a lot more of the work that we were originally doing, more streamlined, especially interacting with the differentiator component, and ended up putting us into a much better state. The other thing was the machine learning service in search, how they had similar concerns, and there was a lot of duplicated work. And we were able to hold off on that until the time was right to do the refactor, and we were able to merge that into the search service. So now we have the search plus ML service that does all of the things that we care about. The last thing that happened to work out real well for us was the fact that previously I mentioned about this proxy to the document store and how we were originally under the impression that, we have to rewrite all our clients to get this to work correctly. And we used this Nginx reverse proxy to deal with that. Eventually, this Nginx server ended up being it definitely got a lot of traffic because everything had to go through these things. But we really didn't have to touch this. So it was a piece of tech that we were able to mostly ignore. Just, it was a thing that existed. It wasn't ideal, but it worked and didn't give us too much pain. Eventually what happened was Platform came back to us and said, okay, well, we actually found a better way of securing customer data, so you don't need to do this authentication anymore. Not only that, we're also going to disable that in a week, so you have to, you also have to, because we need to ship fast, so you need to take it out now. And luckily for us, and I think other teams were impacted differently, for us it was well, that's fine. We just take out the reverse proxy and we're good to go. So it was minimal impact on us because we punted on this technical debt, and we just took it out and we just moved on with our lives. It didn't make that much of a big deal for us. Here are some of the metrics we collected on this work I just described. The things I really want to point out is how machine learning service was a relatively low touch component, and you can see that in the Z-score for the number of pull requests. It was relatively tiny as compared to search and search ML. With the unit test coverage, we were actually, because we were paying off technical debt, we were able to increase the code coverage than what we had with the individual components of search and ML. It's a lot higher with once we did the refactors. And this is also sort of indicative of how ML was a relatively low-touch service. We didn't really make that many commits to it. So, like, for example, so you see here it's about 40 hours between commits, whereas it was closer to 5 to 10 for the search components. And the standard deviation is the same idea, just the difference between the low-touch components and the high-touch components. I guess just to summarize all this up, the idea is that because we were able to isolate these components, we were able to ship faster and also be able to focus on key components while having to touch everything else. If we had actually shoved all this code into like a monolith type service, this would have been a lot harder, especially because we would not necessarily, there may have been coupled code, or it might have been harder to pull apart the ideas that we needed to focus on. We were able to address these bounded contexts as they became necessary, especially with the machine learning component. We didn't have to rewrite that code until it was really the good time to do it. Removing this reverse proxy was relatively easy. We just took it out. It was not too difficult. All this can really be characterized as sort of a contraction phase. So we're basically cycling between expanding, adding more architecture, and then contracting it as we find opportunities to pay off this tech debt. So that's it for this example. Aiton's going to talk about our training architecture and how we saw a similar pattern.
Yes. So, as Chuck said, this example is going to be talking about the training side of our information retrieval and search offering. So first, some background. As you'll recall, our MVP was introducing this whole concept of using machine learning to improve our search results and to enhance them. And what was happening before we got pulled onto this was there was a legacy product which did model training, and it was really a manual process. And so what we were brought in to do is to layer some automation and make it easier to use for the customers. And the legacy service itself was extremely high tech debt, and we're basically, our overall goal, both in this talk and in real life, was to more or less treat it as a black box. The less we had to know about the internals and deal with that, the better it would be for everyone. So this is a view of the services that we designed and wrote. Some of these should look familiar from the previous slides. And with the training data, the search plus machine learning, the document store, and just a REST interface that the customers would be coming through. And here on the bottom right is the legacy service, whole bunch of microservices, whole bunch of data stores, whole bunch of mess. So in order to keep things as quick and as simple as possible for us, we introduced these agents. So the agents were the interface between our services and the legacy service. And obviously, it's not the best approach, but we once again decided to assume technical debt here in order to keep things moving quickly. One of the things which we're going to do for the rest of the presentation is just treat the legacy service as just a black box, since it's not super important to the rest of this talk. But one of the things that did happen here is that we ended up with this here. So late in the game, we get this requirement. Turns out that the process of training models is an asynchronous process, and when things go wrong, there was no way for the customers to figure that out. So what we did to solve this problem was shoved in a new service for handling these notifications. So whenever one of these agents has a problem, it notifies the notification service, and that service is what the customers were able to use to get information out about what had gone wrong with their model training. And as a quick interlude here, talking about the agents for a second, as you saw on the previous slide, we had 3 agents here: preparation agent, cleanup agent, and the monitoring agent. And what we discovered is a lot of shared concerns between them. There's a lot of shared code. We did, honestly, a lot of copy and pasting just to get things up and running as quickly as possible. As we went into the later phases of development, what we decided was it's time to pay off this tech debt. So we reached a point where we really had to deal with it. It couldn't just be pushed off any longer. And what we ended up doing was taking these shared code between these agents and refactoring into shared code base, And actually now all of our training agents, except for one, are now actually based on that shared code base. It's now much easier to get new training agents. So whenever we discover there's a new problem, it's relatively easy to just create a new agent. And one thing which you'll notice here, though, is the monitoring agent. We didn't actually touch that because once we looked at it, we realized it's low touch. It's kind of humming along on its own. It's doing its thing. And we really don't have to touch it very often. It doesn't really have any problems very often. So we just left it alone. And as you can see here, it's an isolated low-touch tech debt item. So more or less continues to this day. But we had a problem. If any of you are familiar with this acronym, that came very late in the game and was another one of those, hey, you have, a limited amount of time to get this done. And so the way we dealt with that is we came to our architecture and said, okay, well, let's just shove another service in. So another expansion phase here where we just said, okay, we have this message queue we have to listen on for customer requests related to GDPR. Let's just shove this service in. It'll just interface like through our REST interface with the rest of the system. A little bit high tech debt, but we knew it was coming. We assumed that tech debt in order to get it out quickly. And that is another thing, which it turns out is low touch. We haven't really had to touch it since, and it's been another thing that just hums right along. So this is our summary of our metrics. And what you can see, it should look very familiar to the slide that Chuck showed you earlier. We've got the search plus ML machine learning component at the top, just as a point of comparison. And then notifications and GDPR as a service, which, as you can see from the number of pull requests, the Z-score for those, very low. It's a low touch, low unit test coverage here for both of these guys. And the bigger one here is the hours, the mean hours between commits and standard deviation. What this paints is a picture between these two of something that really wasn't two components that aren't really touched very often. And when they are, it's kind of sporadic. So here we have the unit test coverage just represented a little more clearly. You can see search plus ML is at 70% versus notifications and GDPR as a service, which are both under 50%. And, we clearly cared about search plus ML and its tech debt versus notifications GDPR, where as a service where we've more or less left it on its own. And once again, hours between commits, the mean, you can see the difference here is pretty stark between search plus machine learning and these two low touch components. And once again, the standard deviation also tells the same story. So to summarize, this is just in this example, we saw an expansion phase where we included the GDPR service, we included the notifications, and we were able to keep that tech debt isolated. And we paid off the high-tech debt in the contraction phase with the agents, where we took something that was high pain, high touch, and high tech debt and really reduced a lot of the pain and a lot of the tech debt associated with it. And if anyone saw the architectural hoisting talk last year, our friend Chuck here and two others, including Michael Keeling, gave that talk and talked a lot about that actual experience, or part of that talk was talking about that experience. So now I'm going to hand this over to Anastas for the discussion and conclusion phase.
Thank you. Okay, so we saw the same pattern, we saw the same pattern in both of these examples. Again, just to hit the highlights, we saw new requirements being met with new components, strategic tech debt accepted in order to meet deadlines, which we consistently did. High touch, high tech debt services were rewritten and combined. The metrics we showed demonstrate that the increase in unit test coverage, which again we use as a proxy for actually doing this, showed increased maintainability, decreased tech debt. At the same time, low touch, high tech debt services remained isolated. Large standard deviations in commit intervals show modifications are rarely necessary and that they're very sporadic in terms of when those are actually necessary. And as I said, for us at least, the overall process manifested in expansion-contraction cycles. So now going forward, we kind of, when this happens again, we know more or less where we are in the process and what to expect and how to plan. Now, everything is not roses, of course. We did make mistakes, and we'd like to discuss these to say how those could have been avoided. One thing that we did particularly poorly is we instrumented our code very late in the game. So we actually started collection application runtime metrics, things like thread pool sizes, how much time is spent in certain methods, things like that, far too late. So this revealed actually many problems that was hidden inside that tech debt that we were trying to isolate. And then once we found that out, it would have been a very simple bug fix, but we just didn't know. So in order to have success with this sort of approach, instrumenting early would prevent this problem from happening. We depended on customers to find our problems for us, unfortunately. One thing that we did is one could argue that we leaned a little bit too far on the implement and ship, and a little bit more emphasis of treating error handling as a first-class citizen would have gone a long way towards reducing a massive support cost that hit us as soon as we released in GA. So it took us about a month of none of us getting any sleep from being on call. And this could have been avoided relatively simply. So that's definitely something to keep in mind of trying to take this sort of approach. So the advantages of how all this played out. Ship fast, isolate tech debt, keep up with evolving product design, meet new requirements quickly, quick iterations per component, and one we didn't really go into but wanted to mention is that inexperienced team members can focus on small code bases. They're easy to understand, any potential mistakes are isolated, easy to keep track of, and a good way of building up experience along the way. Disadvantages. So we were lucky to have a very experienced architect, and we feel if you go back to where I said that, yes, let's accept that we're going to get the bounded context wrong, but let's do a best effort. Well, we don't really have any hard data to demonstrate this, but our feeling is that getting a good first approximation was a consequence of having somebody with a lot of experience leading the charge. So we're not suggesting to just hire 6 people out of school and say, run with it. That's not the point here. We did pay the microservice premium. This is more or less unavoidable until we started templatizing things and reusing code and finding things to extract as libraries. So there is higher deployment and management overhead. We did have high support costs at first. On-call was very unpleasant for a while. We did have to actually pay off tech debt. And this is a part where it's not really up to the engineering team necessarily. It did take a lot of convincing of the product owner. And the only time we actually convinced our product owner to say we need to stop feature development is when we saw that a feature that should have taken maybe a week or 2 was estimated to take about a month because that particular component that we rewrote, that search component, it was such spaghetti code on the inside that we just couldn't work within it. We couldn't add new functionality. And to actually get things into a state where we had that developer agility, that took us months. So that also goes to illustrate that taking this approach doesn't mean write whatever code you want. It doesn't mean just whatever comes to mind, don't even think about design. There should be some base level of care taken, which we did not take with that component, and that hurt us. So that cost doesn't have to be there, and we felt it, and it was not the favorite part of my job. So to wrap this all up, both of the general perspectives, do versus don't on microservices, they make good points. And so by shifting perspective a bit, and rather than treating these concerns about getting bounded context wrong, and by treating them as strategic technical debt instead of risk, starting with microservices can allow a team to keep up with rapidly evolving product design if that is the situation which is at hand. The key elements, at least for us, manifested as an expansion-contraction cycle. As we address new requirements with new components, we expand, we add more deployable components. We isolate technical debt as appropriate. Sometimes we take more on in order to meet a tight deadline, and we isolate that so that it does not affect the others, and that other development can continue essentially uninhibited. And then later, after release and after we see usage of the product, we pay off the technical debt that we have specifically in components that we have identified as mission critical, based on usage, based on the fact that they're low touch, based that they're high touch, because you're not going to be modifying something that nobody is using. And lastly, just something we would have done differently if we had, or that we do differently now that we go through this, is instrumenting early, for example. And we do think that there's there's perhaps a more general approach. As I said, in our case, we had an evolving cloud organization and evolving product design and new requirements coming at the same time. So this allowed us to keep up with all of that. And that's one type of uncertainty, but perhaps there are other types of uncertainty in other situations that would be amenable to being handled with this sort of intentional approach. And we'd just like to end on some acknowledgments. We'd like to acknowledge Michael Keeling, who actually started our team and trained us as we were going through all of this. Joe Rundy, who gave us some valuable feedback during the composition process, and our dev manager, Will Chaparro, for encouraging and supporting us through all of this, especially when we almost crashed and burned right after GA. And that's all we have.
Despite a fire alarm, I think we have time for a question or two. I'm sure there is some. I'll go to the back first and come back forward.
Hi guys, good job. I think you argued the point pretty well, and I'm pretty convinced. But I'm still wondering. It seems to me you actually got your bounded context pretty right in the beginning. So you mentioned, getting your bounded context wrong as considering that to be technical debt and paying it down as soon as you can. But it seemed to me like you got a lot right, and that might have led to some of the success of this approach. Would you agree with that, or can you expand?
There are some things we didn't go into for the sake of time and brevity, which is, if you recall the diagram with the GDPR as a service going through the REST facade, there's actually a lot there that's duplicated because for some of the GDPR requirements, we have to delete data on demand. And so we actually copy-pasted code across different places. We hadn't maybe segregated that well, but we just didn't have to touch it at all because it's a legal requirement that's not changing. We met it. So there's more that we didn't touch. You are right, though. We did get a good first pass, and that's why I emphasize the point of having an experienced lead. Without that, perhaps it would have gone more poorly.
Hi. Thank you for the nice presentation. All this time we have been talking about the technical debt. On the code stand, I understand we have tools to give us the technical debt. But how did you figure out, or how did you calculate the technical debt on an architecture level or a design level?
That's a good question. That's not something that we attempted to do. One thing I will say is that one of the reasons we didn't have some of these more sophisticated measures is we had so many deployable components that we just didn't instrument them all, and so we didn't have that data available. It's something we'd like to do. Was there something?
One of the things which we didn't really mention because it wasn't really quantifiable was the thing that drove us a lot of the times when we had a contraction phase or a refactoring was which of these components is keeping us up at 2 in the morning. The pain level, thank you. The pain level that we were experiencing based on, it wakes us up at 2 in the morning, or it's always firing off these false positive pages. That kind of stuff was a factor in our decision while we were doing things.
That's big. And actually, that was something we were trying to quantify when we were doing this work. Like, when we were putting together the different ideas for metrics, we were actually thinking, like, okay, how can we measure, like, how can we quantifiably measure, like, keeping us up at late? And unfortunately, just like a lot of information was lost to the sands of time by the time we really cared about it. So it was hard to measure, but that's something we've been thinking about anyway.